So example 2, I know it looks like a lot to copy down, and you can copy the whole thing if you want, but we just need the basics. So imagine your perfect day, and then don't lie to me, I know this is your perfect day. It's outside in the sun studying calculus in June. And if you don't think it's your perfect day, trust me, in June this will be happening. You'll be wishing you're outside, but guess what? You'll want to be studying calculus. So your textbook reaches a temperature of 30 degrees outside in that sun. But when you bring your book inside to a room that is 22 degrees, it cools down. So 20 minutes pass before the book cools to 25 degrees Celsius. How long will it take the book to reach to 22.5? So again, the first part of this cooling is going to cool down really quickly at the beginning because it goes from a hot outside temperature into a room that is obviously cooler than outside. 22 degrees is right around room temperature. And so it cools quickly from 30 degrees Celsius down to 25. I'm curious about that next little section. How long will it take to go from the next one? So if you wanted, you could push pause here. And if there's lots of time, then the class can go up on the whiteboards and go ahead and do this. I'll let the teacher and the class decide if that's what you want to do. If not, I'll just move on and go from there. But the steps are exactly the same as what we had before. So first we have to find out this C value. Again, logically we can tell if the temperature was 30 degrees, when it walks into that room that's 22, there is 8 degrees that must be the temperature itself, because 22 of the 30 degrees, 22 of it is made up of the surrounding temperature, so 8 of it must be the actual temperature of the actual book. Let's see that happen. So step 1 is find C. So again, we will use the same formula, T equals C, capital C, excuse me, e to the kt plus s. We're considering the beginning. So at the beginning, the temperature is 30. The C we don't know. Don't worry about K because it's going to be gone. The T is 0 because we're at the beginning. And S, the surrounding temperature, is 22. We're considering the beginning being when you walk inside, not when you're outside. So if I plug in this information, 30 equals CE to the K times 0 plus 22. Of course, all of this is going to be CE to the 0 plus 22. So of course that will go to 1. Anything to the power of 0 is 1. So then it's just 8 equals C. And we get that. So there's step 1, the new part for today's lesson. Everything else should feel just like what we had before. So step 2, we got to find K. And we'll use the snapshot to do that. So T equals CE to the KT plus S. C we just figured out was 8. K we don't know. T we'll find out in a second. S I think I remember was 22. But I got to go back to my scenario, my question, and figure out what it is. I'm going to look at that snapshot. So I walk in there, and the snapshot is 20 minutes pass before the book cools to 25. So the temperature at the snapshot is 25 degrees Celsius, and 20 minutes has passed. So that snapshot will allow me to figure out what K is, and then I can go off and find any spot on this function. So 25 equals 8 CK to the 20 minutes, this case, plus 22. Subtract 22 from both sides gets me 3 equals 8e to the 20k. Divide both sides by 8, so 3/8 equals e to the 20k. I'll give you a second in case I've gone too fast. Hopefully you've had a chance to do this on your own and you can just be checking my work. Now I need access to that k, so I got to take the ln of both sides. And I think I'll bring down the exponent at the same time this time. Ln e. That's going to be 1. And on. So I'll just divide by 20, and remember when I divide by 20, I'm going to write 1/20th ln 3/8. And really the only reason I do that is so it's a little bit easier to write in the next step when I have to write this little tiny exponent with all this stuff in it. All right, so I figured out my k. I'm happy with it. Now I'm going to go off and actually answer the question. So, same formula, C equals KT plus S. I'll get all my variables. K I just figured out, well, 20 I figured out in the first one was 8. K I just figured out was 1/20th ln 3/8. T and S is still 22, the room temperature, or this room's temperature. And I'm going to go figure out what was this question asking me. So I'm just going to go back and see. And it says how long. So again, I have to figure out the time till the book reaches 22.5. So my temperature now in this question is 22.5 degrees Celsius. And I have to figure out how long. So again, I'll give you a moment in case you haven't to just get ahead of me, sub in and solve for T. Subtract 22 from both sides. 0.5 e to the 1/20th ln 3/8 t. Divide both sides by 8. And I get 0.5 over 8, which I don't like. So I'm going to double the numerator and double the denominator and make it 1/16th e to the 1/20th ln 3/8 of t. Taking the ln on both sides and bringing the exponent down at the same time. First ln of e is 1, so now I just got to divide both sides by this to get access to t. So it's ln 1/16th all over 1/20th ln 3/8 equals t. And punch that into your calculator. I'm not going to use my calculator, I'm just going to do it off the top of my head. And I think it's around 56.5 minutes. And it turns out it takes 56.5 minutes to cool the extra little bit to 22.5 degrees. So example 1 and 2 are exactly the same, just from different numbers. I just had a chance for you to see how to answer these questions. So that's pretty much it. We're done. But before I go on, I'm just going to ask an interesting question, just something for you to think about. I'm not going to answer it. But I'm curious about how long it would take to cool to 20 degrees, and if that's possible. I'll let you think about that. That might be a good thinking question to talk about later on. How long would it take to cool to 20 degrees? And is it possible? Lots of different answers and explanations for that. Okay, so your practice today is going to be a worksheet. I've left that with a supply teacher. Just a couple of questions. You're going to find that very similar to the ones we just did here. The first few just get you used to using the formula, but you could jump right to number 2, 3, or 4 and go off and answer it. The answers are on that worksheet, and I wish you luck.